Hey, my name is George, and today at the conference I'll be presenting on how to integrate the Slack messaging app with the Wolfram Cloud and Wolfram Database. Hello everyone, my name is George Varnavides. I'm a graduate student at MIT, also studying material science and condensed matter physics, but unlike Kyle, I will not be talking about any of that today. Hopefully I'll be trying to appeal to a more general audience by talking about how we can use the Wolfram language to script very easily some sort of little apps on the Slack messaging system and some other sort of productivity things. Okay, the talk is right before lunch. I was told to wrap it up early when that happened, so we will be doing that, I think. But feel free to stop me and ask some questions. All right. Okay, so have you guys used Slack? How many people use Slack in the room out of curiosity? Okay, perfect. Yeah, I think it's great as well. So for those of you who don't know, though, Slack is sort of a workspace messaging app. And it's nice because it can integrate like a number of sort of classical collaboration tools that we require. So for example, it integrates emailing, scheduling. You can even do conference calls with multiple people if you're in a paid workstation, stuff like that. Apparently, it started off as this searchable log of all conversation and knowledge, which I thought was a fun fact. And I'm sure everyone here at Wolfram can relate that that's sort of a good endeavor to, it has since taken on a life of its own, which we're going to talk about. So the good thing about Slack is that in addition to being all of those, like sort of like its personal chat interface, email, scheduling, whatever, it has a lot of built-in apps, and it has a command line-like interface, making it very easy to code if you like some of your own apps. So maybe we should, so this is sort of how a typical Slack workstation would look like. So here I have my 3 workstations that I'm currently using. In any particular workstation, there's different channels. It's quite clear that, well, okay, we use our channel with a lot of language, and then you can also directly message some users. This is my sort of personal space, and just to illustrate these widgets and these apps. So for example, there's this command line where I just do / and then these built-in commands appear. So for example, by doing this away, I sort of toggle my status as being away. That's sort of a simple thing. I can then come back and say, actually, I'm active. I can also just use this to type. Stuff like that. Okay, so this is sort of how the basic Slack user interface works. And the idea is that we now want to come in and do sort of our own / commands that look kind of like this. So this is, for example, one of them. What are you talking about today? Okay, so when this abstract was due on sometime in July, I thought this was a cool idea. So I started playing with it that afternoon. The testament to this is that this is really easy to do. I'm only going to show you like 10 to 15 lines of code for every app. And it really is that easy. If you do want to do something fancier, which I would talk at the last slide, like do OAuth authentication, then maybe Kyle is the person and Laura is the person to talk to. But to get up and started, it's really quite easy. All right, let's get started. Okay, so I'm just gonna, all right, let me just illustrate, oops. There we go. Another app that I have already, so everyone does 2 + 2 to make sure that Mathematica works. I never understood that, so I coded an app that adds 3 to a number. So we're gonna add 3 to 10, and hopefully that comes back with 13. Excellent, everything seems to be working. I also, if I do this, I also have this sort of help thing, which has the optional arguments of the number to be added to 3, stuff like that. So we can code all these. So how do we go about doing something like this? So essentially what the / command does is it just sends an HTTP post to a specific URL that we're going to specify. And that post has a particular payload. And the payload looks something like this. It has a token, a team ID, a domain. But the more important fields, or the ones I'll be talking about today, are sort of the text, the response URL, which is where we need to send information back to Slack, and maybe your username if you want to do something with that. So sort of the first step is to figure out how to read the payload that Slack gives us. So there's this HTTP request data, which pretty much can either read the body or the tokens of the HTTP request. If you do HTTP request form rules, it'll give you everything back. So here, I'm going to be making this sort of modularly. I wrap inactive or delayed, because if I were not to do that, it hasn't received an HTTP request to perform any of these operations. Okay, so that's sort of just the bare bones of how we're going to go about reading the payload that Slack gives. Okay, and like I said, the two things we really care about is the text field and the response URL. So the text field is everything that comes after the first space of the / command. So you do add3 space, whatever it is you want to do, that gets parsed as a single string that you can then manipulate and do whatever your code would do, and then there's a response URL. Again, if I make this information that gets back from the HTTP request as an association, I can just extract the text field really easily. There's really nothing fancy happening out here. Okay, and now we're going to try and perform some computation. So let's see if we can try and code this Slack app in real time. So I'm going to, for my computation, I'm going to do this, which is a super easy way to get any text to compute in the Wolfram language. So say I want to do the standard 2 + 2 as a string. It gets interpreted with the interpreter as an expression, and the Wolfram language, it does it. We don't particularly need to talk about this, but it's sort of a workaround. Okay, so we have something like this, or we can even have something like integrate x. Let's do something slightly more interesting. Cosine x, sure, let's do this. So any string can then be parsed as a Wolfram expression. So that's pretty much what we're doing. We're reading the text, we're passing it into this interpreter, and then we're making the result be a string so that it can get parsed back into the app. And this is pretty much the entire app, or at least the computation that goes behind it. The next thing that we ought to do is that we need to figure out how to send it back to Slack. So the same way we got an HTTP GET, now we're going to reply to that Slack URL with an HTTP POST. So it expects a JSON formatted file with some set fields. The most important one is text, where you put your result, and then there's other fields like the response type. You can set it to ephemeral so that it only appears on the user that did it, or you can also, if you were to do this in channel, it would appear for everyone. Okay, and then finally, now that we have our, and this could be an export form or a string, but it has to be exported somehow as a JSON. Once we have this, we need somewhere to store this on a server somewhere so they can accept the HTTP request and enter the Wolfram cloud, which is indeed very convenient for our needs. Because in this simple line, this is the function that we were just coding, which just reads the HTTP request, pulls out the text, does this little computation using the interpreter, formats the output as a JSON, and then it just puts it up on the cloud. The importance of delayed here is that we only want to perform this calculation when every time, rather, Slack would sort of send one of these HTTP requests to our website. All right, so let's do this. And now I need to copy this address and then go over to Slack. I'm going to go to my apps over here. Oh, okay, I already had it open. So this is the apps, and it's really easy to make. I just made one that says Wolfram Technology 2018. You can go to /commands. You'll see I already have a couple. The add3 is the one I showed you, so we're just going to do add new command. We're going to call this /Mathematica input. The request URL is exactly that URL that it has to get received at. Description needs a short description. All right, and then we're all set. We're going to save this. And that should do it. And if we now go over here, we now have, this new thing, Mathematica input. And if I were to do 2 + 2, hopefully it should come back as 4. You can also do Mathematica input, again, this integrate command, and that should also come back. So super easy to do, 4 or 5 lines, and then we get most of the flexibility of the Wolfram language, or computation that we can run in the cloud, I should say. Of course, this gets parsed as a string. but we can use the interpreter to do things like plot. If I were to convert this as a string, it would just read it as a graphics 3D. We could go the route of Mathematica 1 and do this as AC art. We could also just rasterize this picture, put it up somewhere on the cloud, and then add an attachment to the message that we send. So there's just another form that goes into our JSON that we do back, and I do the text saying graphics results attached, and I add an attachment which has an image URL, which again is the result that we just created, exported into the web. So I'm going to use this one instead. I'm going to go back to Slack, and we're going to, let's see, we're going to change this guy now to this new URL. And if everything worked, now we should have Mathematica input. Let's see, plot 3D. Will this work? Please enter a valid expression. All right. We'll just use this result. Well, that didn't seem to work. Excuse me? Oh. No, I think it should. I think this is still a graphics, isn't it? Okay. Interesting. All right, so let's add that. Thanks, Kyle. Okay. All right. So then we get back the result as an attachment. Okay. So that was sort of this super easy coding it on the fly to get at least some of the functionality of the command line of Mathematica. Why is this useful? Well, this is one example that it was, or the way I started thinking about this in my lab. So we have this sort of local library of books that we use in our lab, mostly physicsy books. And then these books are either loaned out to some people or not. And we wanted to have this interface where you can check which books are available, whether you can check out a book, stuff like that. So we just made a couple of different commands to do this. One is sort of the inquire command. I thought this was pretty funny. You can get some really funny loading messages from the SimCity app, in case you were wondering. So like, please wait, bureaucratizing bureaucracies, or something like that. Or please wait, asserting packed exemplars. These are pretty funny loading messages. But then the actual code is, again, not entirely complex. I mean, it looks a bit long because I'm adding sort of some useful help text. So what the user should do if there was an error and some error catching, stuff like that. And then here is just me parsing that string. And then finally, again, sending the result back as a rasterized image. One thing to note is that Slack expects an original HTTP reply in the first 3 seconds, 3 or 5 seconds. What that means is that if some of your computations you expect them to take longer than that, so the thing doesn't time out, you usually first have to send an original HTTP request, sort of somehow informing the Slack that you've received that and everything's okay, but also somehow telling your user that everything's fine, I'm just loading your message, and that's sort of where the loading messages come in. So we do this using URL submit, which is asynchronous, and then we can continue doing our entire computation, and then again, once we have a result, send back this URL submit asynchronously to Slack. So Slack allows, it requires this in the first 3 minutes, but then it gives you a window of 30 minutes for that URL is active to send anything back. Okay, so what are we going to do here? We're going to do bib inquire. And I'm just going to see, I want to see all the books, and I want to see the authors, the title, and see the status of the, please wait, relaxing splines. Okay, and then we get back our data set that says that these are the books that we have in our library, these are the authors, and these are the statuses of the book. I mean, I can go further than that and say, all right, I want to check out this book, which title is The Physics of Phonons. It's actually what I work on, so if anyone has anything to contribute to the physics of phonons, I would be really happy to hear. And I want to borrow it. Whoa. All right. Well, I'm not entirely sure why it says it didn't work, because I think it might have worked. Well, that's what happens when you do live coding, right? But if I were to go back and check my library now, I think it ought to say that that book has been checked out by me. Database Q is equal to true. Okay, so that book was successfully loaned out to G. Varnavides. This is sort of the Slack username, so that's another one of those tests or those fields that gets parsed as the payload, and it automatically assigns it to me. I mean, this is sort of a simple example that we found useful in my lab. And then I think a last thing that is presumably of interest is, okay, and that's the borrow renew command. But what if we want to interact with data? So it's really quite common when you're in a Slack workstation to be sort of uploading text files with data, sort of exchanging with your collaborators. And it would be great if we could somehow have access to that data to visualize. Like I said, this is cheating because I'm going to create create a public URL to do this, but the actual API does sort of provide this oath authentication if we wanted to go down that route. Left as an exercise to the reader. Okay. The code is here. Let's see, do I want to say anything about the code? Not really. The idea is that it's just going to take the link and it's going to reformat the link and route it to the address that it auto-downloaded, and then it will execute that URL downloading the data, and I'm just going to list plus the data and then pass it back again as an attachment. So the way that would work over here is that I could come over here and say, I want to add, let's see what I have in my documents, as example data.mx. So now I've added it to Slack. I'm going to come over here. I'm going to say create external link, copy that address, and then I'm going to do visualize data, link, copy paste. And the name of the file is example data.mx. And then we get back the result happening, getting list plotted with Mathematica. This is a particular example from the list plot help section. Right, like I said, like all of these, the actual link and the name could be automated, and you can also have events where every time a user uploads something, it sort of triggers this event on the app, and then it says, okay, something's been uploaded, get the token, do the oath authentication, and then you can transfer data back and forth, but this was all an afternoon could spare me. Yeah, I think I'm going to stop there unless there's any questions. Yeah. Excuse me? So everything that I've shown is in this notebook, which I've given to the presenter-ready people. So I'm guessing it got uploaded in Pathable. If not, I can add my file to Pathable. You mean in the form of a package or something? I'm not entirely sure it's that sophisticated. I could, but it's really quite easy to get these started in these 10 lines that are in the notebook. Right. Yeah. I mean, ideally, if you were to create a link for this, you would want to go down the bot route to do this authentication. So you can have a sort of this Wolfram bot that's sitting on Slack, and every time you want to interact with it, you'll do @Wolfram bot visualize data for me, send data to @Kyle or something like this. And that can be done, but yeah, it has not been done by me. Yeah, actually yesterday I was debugging this to some extent with Craig, and yeah, you can send it either to a different channel or, so here I was sending it to Craig. I could also send it to a particular channel. And like I said, this is also where the ephemeral and the in-channel things come in. So for this one, the text that I gave it or the instruction is in channel, meaning that it prints also the command and the person that did it and then the result. Whereas if we were to do something like add 3, this is ephemeral, which means that it's just going to come back with the answer, and there's no, and this would only appear to me. So if I were to do it in the channel with Craig, this will not appear. I think actually I might get only visible to you. So you can figure out who your commands are visible to. Well, that's more of like a draft space where you can do notes, yeah. But I do talk to myself quite a lot. Right, so if I were to go here on my apps, these are, so in the settings for the apps, you can set authentications and permissions for particular users, but by the default, when you install it at a particular channel, everyone gets sort of the same authorship of this. So the authorizations that this app has, it can confirm user identity, it can add / commands, and it can access the workspace files. So in this particular workstation, so anyone that has access to this workstation can go. So in this particular workstation, it's quite boring. It's just me and Craig in this particular workstation. But in other workstations, for example, for my lab, there's on the order of 15, 20 people, and all of them can then access that particular command. Just to make sure that, yeah. Yeah. And you can have guests at particular channels. Like you only allow them access to this particular channel, and they can only see these things. So there's quite a bit of flexibility. So for example, right, I pushed up this application, and then I was testing it, and then Craig comes in and does the same command, and it works for him sort of out of the box as well. So anyone that has access to that channel. Okay. Yeah. Well, she doesn't particularly know. Well, she does know that I'm here, but like I said, this I wasn't kidding and this wasn't some sort of me patting myself on the back. This was one afternoon's work, so I think she'll be okay with it. Hey, I made a library for the lab. Come on. Okay. Well, I'll be here as well until Friday, so feel free to catch me. Thank you.